class, what's a good analogy? What's an is-a relationship that we can use? There you go. We'll do a class shape. And we'll do a class square extends shape. Except shapes don't do anything. What can you do with a triangle? All shapes can have a number of corners. Count corners. Is this polymorphism? Yeah. Well, this is necessary for polymorphism, but it's a trick question because I'm a professor and the answer is no. Is this polymorphism? No, that's inheritance. Is this polymorphism?
Yes.
Nope. This is, what is this? Overriding?
Yeah, overriding.
This method overrides the nothing, the abstract, that thing that's part of shape. Or this is implementing, I guess is probably the more correct term. So this is an implementation. Abstract means there is no implementation. So where is polymorphism? Yeah, it's not in any of these. Somewhere else, I might have a static void do something function. And if I say square s equals new square, is that polymorphism? No. Do something else. S. And then let's suppose I have this. Static, do something else. Shape S. You're following my code as fast as I'm typing it, right? Okay, that's partly why I type it rather than prepare it beforehand, is it forces me to slow down so you can actually digest it. But suppose I say system.out.println s.count corners. Is this polymorphism?
Yes.
That right there is polymorphism. Why? Because what is S?
Shape abstraction of.
You might say it's a square, and it is if it got to this function through here. Meaning if on the call stack, do something called do something else. I'm so funny because I talk funny. But it's quite possible there's some other function somewhere called, I can't think of a funny name now, called something else that calls do something. Ah, that was bad. It's quite possible there's some other function that calls do something else, and it passes a triangle, right? So what is S? You don't know. That's the important thing. You don't have to know, and you can still do something else without knowing what S is. All you know is S is a shape, because all shapes can count their corners. This code won't compile, why not? What's wrong with this code? Yeah.
Class shape is not abstract.
Oh yeah. It's not the one I was thinking, but that's correct.
Triangle doesn't have a count corners function.
That is the one I was thinking. Triangle doesn't implement it. Now in C++, actually this will compile because we don't instantiate triangle anywhere. And if you instantiate it, then the compiler says, hey, you can't instantiate an abstract thing. Whereas in Java, it doesn't even let you compile unless you have either marked everything as abstract or satisfied all the requirements. If I did this, it would compile. Because abstract means, I know I haven't satisfied all the requirements, just go with it. And that's kind of what abstract means. That's what it means here, it's what it means there too. If you don't say abstract, then you have to provide it for the compiler to not yell at you. And now the code will compile, assuming I haven't made any inadvertent mistakes anywhere. Oh, so I can pass this square to this function. The question is, can I also pass a triangle to that function? could I right here say triangle T equals new triangle, pretend I spelled it right, do something else T. Can I do this? Is that your question? In fact, this code is perfectly right, and that's what I want to have you stew on for a minute and think about why this is right and how it could possibly work internally. So yeah, in fact, I have a square right here, and I call do something else, passes the square, and I make a triangle, I pass it, and a triangle goes over here. How can this function possibly work? Because when it compiles, is the compiled code going to work with triangles, or is it going to work with squares? Do you see why there's even a question? Okay, which way is the compiler going to make this code operate? Yeah, so essentially, this is what a shape looks like. Shape has all of its guts inside of that square. And let me make two of them. Can you allocate just a shape? The answer is no, because it's abstract. This is what a square looks like, and all this stuff you put in the square class goes in this region, and the stuff that goes in the shape class still goes in that region. And we'll say this is what a triangle looks like, and maybe triangles have more stuff than squares because trigonometry or something, whereas squares only have that much guts. Do you know what I mean by guts? Member variables and methods and whatever you happen to want to stick in it. But all shapes maybe have a squiggly purple thing. Okay, well, the do something else method, briefly look at the code. See, do something else takes a shape as a parameter. Well, it's impossible to have a shape. There are none of these, by which I mean it's impossible to have just a shape. There are none of these on the heap. You can't even get one of those alone on the heap because you can't allocate an abstract class. The only thing you can do is abstract one of these or one of those. You can allocate a triangle, you can allocate a square, but you cannot allocate a shape. Kind of like you can give birth to a George or you can give birth to a Henry, but you can't give birth to a human. That didn't come out right. You can't give birth to just a human without it being a... Never mind, bad analogy. You get what I'm trying to say. Before you name him, I guess. Yeah, it was a terrible analogy. Forget it. The point is, these are the only things on the heap. So you're going to pass one of these to the triangle, or the do something else function. And the do something else function is basically just going to be compiled such that it will only look at this part. And as long as it doesn't look at the other part, it doesn't really matter what you passed in, right? Because the other stuff will just be ignored. So as long as you don't look there or there, you know, it's all a shape, right? And so it can just work with a shape. So notice this do something else method. If I were to do something like this, suppose in my square class I said, string name equals Henry. And then down here I said system.out.println s.name. Will this compile? No, it'll tell me, hey, Sprite doesn't have a name. And you'll come up here and you'll say, wait a minute, my SquareX, Sprite, shape. It'll say, shape doesn't have a name. And it's correct, shape doesn't have a name. But you'll say, wait a minute, square extends shape. So square is a shape, right? And square has a name. So, isn't it right? Well, at this moment, S does have a name when it's passed as a parameter, but do something else doesn't know that it has a name. And because it doesn't know that it has a name, it can't use it. And the next time it's called, the second time, it really doesn't have a name because now we're one of those different types of objects with different types of guts. And so it's correct to enforce that you can't access name in shape because it's not really in shape. It's in the square part of the shape square. Does that make sense? Okay, so that's how it works under the hood. This function really operates on shapes, even though there are no objects that are only shapes. And so when writing very general purpose code, you want to write lots of this kind of stuff, functions that can operate on anything. For example, suppose you're doing, say, collision detection. Wouldn't it be nice if you just compared two sprites and you don't really have to know if you're checking whether a Mario intersects with a Goomba, or a Mario intersects with a tube, or a tube intersects with a Goomba, or a fireball intersects with a Goomba, or a fireball intersects with a tube, or a fire, you know. You don't really have to even think about it. You just think, sprite, sprite. All sprites have an X position, a Y position, a width, and a height. And if we can check whether they overlap, problem solved. I will never have to think about it again. I will never have to debug or solve that problem again. It will just work for my entire video game. And now you're coding along and you think, oh no, did my Goomba crash into the tube? Should he change directions? Oh, I have this handy do my two sprites collide function, and now you realize polymorphism is your friend. See what I'm getting at? Okay. So, any questions so far about polymorphism?
So how would you get the name of this square?
Okay.
Would you have, like,
Let's suppose in here I knew that S was a square, and I want to print out the name. It's a good question, by the way. I could very well say square squa equals square S. What I'm doing right here is when you put a type in parentheses, this is called a cast, and it says, hey compiler, I know better than you, trust me, this is the real stuff. Make that type be this other type. And so now this is a square, and so this assignment works. So this puts a new variable in the stack, and it points to the same thing that S points to. So it's kind of like one of these. There's already a variable pointing to the, there's already a variable named S coming from the nebulous stack that's off the edge of my screen, pointing to the sprite portion of that object. And I'm now adding a new variable on my stack pointing to the square portion of that object. Now, as it happens, they're both pointing to the same place in memory. It's just that the compiler knows that one of these variables, even though they contain the same number, the compiler remembers that this one points to a sprite or a shape, and that one points to a square. And so it's really at compile time where most of the rules are enforced. In Java, casts are enforced at runtime, so they do slow your program down slightly. It's not worth worrying about. And now I can say system dot, well, now I can just say this. But I can say sq.name. Or if you prefer difficult to read code, you can cram it all into one line like this, which you should never ever do. Bad, bad, bad. But people do, and when you see code like this, you'll know the first thing you should do is clean up their dumb code so it's readable, because people should never write code like that. But yeah, make it look as simple as you possibly can. Now, it looks kind of confusing to see parentheses before a variable and parentheses after, because this is a function and this is a backwards function, right? Now it's a cast, and it takes a little while before it sinks into your brain and you look at this and it doesn't make you think they're calling a function wrong. It's really just a cast. Now, another important question, when would this ever be safe? We don't actually know it's a square, do we? All I've really done is kind of ruined my do something else function, because now if you call it with a triangle, well, it's going to throw an exception right here because that triangle is not a square and it will fail the cast. So when is it ever okay to do that? How could we possibly know if S is a shape?
check its type?
Yeah, we could check its type. And it turns out polymorphism solves this too. Now, there is another solution, and I'm going to just ignore that for right now and show you how to solve it with polymorphism. Okay, there's a good reason for that. not all languages support reflection like Java does, and most object-oriented programming languages support polymorphism. Therefore, learning the polymorphism solution will help you in all situations. The reflection solution will help you as long as you're programming in Java. Therefore, let's do the better solution. Okay, how about let's add a function named, what should I call it? Boolean mi square. Now, simply by having added that one line, I can recompile my code, and the compiler will force me to add an MIS square function to every single shape that inherits from shape. You see how that's actually useful? So usually we think of compiler errors as bad. Oh no, I got a compile error, right? The longer you program this, the longer you'll realize, yay, I got a compiler error. That's basically a, here's all your bugs, go fix them, and you'll start to even utilize that. You'll start to create bugs on yourself to offload remembering changes that you need to make, and it just becomes part of programming. Compiler issues are so easy to fix compared to runtime issues that we like the compiler, right? So that's exactly how I would do it. I wouldn't even bother going to all the places and trying to add this function. I'd just compile right now, because then I get a handy list of all the things I need to do next, and then I'd start doing them. Less I have to keep in my mind, the more I can focus on stuff that matters. So the compiler will say, hey, you can't implement a square. It doesn't have one of those. So Boolean MIS square function, return true. I don't see any reason to dedicate 4 lines of code to this because it's pretty easy to read anyway. So yes, I'm violating all of my indentation rules here, but actually sometimes I think sanity trumps rules. There you go. Now I can come down here and ask something like, if s.mia square, then now do you see that what this code will do is it will, no matter what type of shape it is, it will count the corners. It will say 3 or 4. But if that number happens to be 4 and it's a square, then it will also say Henry. My, what useful code I have written, huh? Obviously, this is a pointless exercise in demonstrating polymorphism. Let's see if we can now translate it to something more useful.